can turn around real quick and tally them up and get them back out to you, I will, but I can't promise you that. But they're exactly where I expected to be. Across the board, we're good on the first couple days of factory, which is good. The thing that I tripped up a couple of is that pesky GCF. Totally expect that. It always does. But even then, I saw, compared from other years, it was actually an improvement from other years. So I was happy with the new quizzes out. Okay. A few people here and there, but across the board as a whole, you guys are factoring stellar, so let's keep up with it. So let's continue on here. Let's go over first off questions from last night. We didn't change anything major yesterday, did we? All we did was add A as composite now. So instead of what, 5, you have 6. So 1 in 6 possibility, or it's going to be 2 and 3. That's as crazy as we got. So this is your call. All right. Anybody have any particular questions from last night? I can do 5. Maybe I can do 5. Let's take a look. 5 is a good one to talk about. And actually, I'm going to talk 3 and 5 at the same time. There are 2 binomials, and this is where one of the trip-ups kind of happened yesterday. So let's talk about number 3, and then we'll talk about number 5. 3 was a little bit of a trip-up, totally expected. All right, on number 3, it is a binomial, so is number 5 a binomial. But we have a 0 up there. Where that 0 is completely changes how we tackle that. Which one up there has the constant that is 0, 3 or 5? Yeah, thank you, right? 3 has got the constant that is 0. So when you look at this thing as a whole, we always do standard form, but it is. And I would say GCF, but as we just kind of look at, again, quickly ahead, C has got the 0 here. And because C has got the 0 on this one, we got to do our what? GCF. Now, the mistakes that I saw from that mini quiz of from this one, this was the question 4 in the top right. Somebody just didn't bring up the greatest common factor. Okay, 6 and 24. The GCF is 6 there, but some of you just brought out a 2 or just brought out a 3. You didn't bring out everything. I think it was a 12. I think it was yesterday. So here the GCF is 6. Then for the variables, some of you didn't bring out a variable. You could have brought out, I think it was an M, and some of you just brought out like 12. Here, 6P is the GCF, and when you take that out, we undo multiplication by division, and show me what you have left over. And that P plus 4 is when we go through and divide it. And when we go through and divide that, 6P squared divided by 6P, 24P divided by 6P, there we go. Okay. Now, 3 was not bad, but there's those little mistakes. Now let's take it to 5. 5 is very similar to binomial, but where that 0 lands makes the difference. In this case, we have B as 0, and when B is 0, we change nothing. We keep doing the exact same thing of factors of A, factors of C. Now there was no GCF to start off with. We can't bring the size of those numbers down. And we did a few of these yesterday, and you had probably a little bit of practice it with here tonight. There, on this one here, when B is 0, there actually typically is kind of a pattern happening here. I don't know if anybody's caught the pattern yet. Before I go here, trying to build this, what's my signs for -9? Sames or opposites? Okay. Now we have 3 possibilities here. We only did 1 with 2. 16 breaks into what? 1 and 16, 2 and 8, 4 and 4. So we have 3 possibilities. Only 1 is going to work for us. That's where I said you can get a little pissed off at me because it just takes some little time. But there is a little bit of a pattern here. Anybody catch anything special about these numbers, Jackson?
If they're the exact same, for example, 1 is positive, 1 is negative,
okay,
that would just equal 0.
Okay. So of 1, 16, 2, 8, 4, 4, what are we looking at? 4, 4. Adeline, I saw your hand up go too. What were you about to say?
I was going to say 4, 4.
Okay, so here's what's happening. Let's go back to the beginning of the year when we started talking things. 16 and 9. What is 16 and 9? Those are one of our special numbers there. Perfect squares, thank you. Those are perfect squares. Perfect squares are happening again. And when you see a binomial, when B is 0, and that's what Jackson Adeline was kind of alluding to, you got 4 and 4. You typically get perfect squares right here. So instead of doing 1/16(2)8", I'm gonna go straight to those 4s. And when you see 16 and 9 like that, b is 0, think square roots. Okay? Is that true every single time? No. But for the most part, when we're doing factoring like this, it is pretty much true. Positive and negative. Again, we are checking that multiplication right here for the linear term to drop out. And it does. So b is 0. Keep on the eye for perfect squares. Okay. If you caught that, great. If you didn't catch that, who cares? You can still do it. Maybe not quick, but it still goes. All right. Anything else anybody's got from anywhere? Yes. 10. Let's go on the flip side of things. All right, number 10. Let's look at 10 here. That's a large number. So first thing I'm looking for is GCF. Bring out a 5. That's the best we can do. Now, one thing I noticed, this was the last. Oh, that is 9, isn't it? My bad. Thank you. Well, before I do anything here, back to GCF. Let's also go with 10. Some of you, it was the last question. I think is number 5. Some of you, when you brought out the 5, you didn't divide correctly. I think it was also 5 on the mini quiz yesterday. Use the calculator, but some of you cannot take, I think it was 80 divided by 5, I think it was. It should have been a 16, and some of you put like 12 or 10, I don't know. But make sure you divide correctly. So we go over to here. Let's try it. 10 actually, bless you. Okay, got some little bit large numbers, so I'm looking for a GCF. This is where I'm taking my calculator. I'm taking 42. I know 42 doesn't go into 36, so I'm backing that back down. I'm thinking some factors of 42 that might work. So maybe a 7. All right, a 7 I'm trying. I don't think it works right there yet, based off the answer. So I'm bringing out a 6. So when I bring out that 6, starts it off 7p squared. And what do we just say we're bringing out? 138. So what's 138 divided by 6? So I get that. Yeah, I'm not thinking today. 23. And 36 divided by 6 is 6. All right, there we go. We started off. Now, brought down the size of our numbers a bit, and A turned out to be 7, B is 23, and C is what? 6. This goes back to day 2, okay, where A turned out to be prime, turned out to be 7. 6 is what? Positive, so same signs. And what are those same signs? Pluses or minuses? They're both going to be pluses because there is no minuses in there. So 7p, 1p, plus and plus, and trying to get that magic number of 23 out of there. Based off of their suggestion, and again, what I'm just sitting here doing, I'm taking 7 times 6 is what? 42. 42 paired with a 1, that's going to be way too hard, way too large up there. And then maybe a 7 times 3 gets you to 21. That's pretty darn close to 23. So that's what I'm doing in my head. Some of you gave me this answer on the quiz, but then what did we forget to do? At the very beginning, you forgot that GCF that we pulled out. You got to bring that along for the ride. Okay. All right. So we're going to get more practice here today. We're going to do one more twist on things today, and I think that will be the last of the twists that we do this week. Okay? So, the usual, make sure your name's on it. It's not fully completed. Again, don't turn it into me. Take your time on it. Get it into me tomorrow. Don't just write down stuff to write down stuff. Get the practice in. Okay? And get out your notes, and let's pick up where we left off. Okay? Find that page in your notes, please. Today we solved. Don't need any calculators again. Just need your pencil and your notes. Okay? Just need your pencil and notes. Find that page in the notes. We solved. So we've been looking at what we say is expressions. We're going to do any solving right now. We've been factoring what we say is expressions. Now today is when we start solving things. We're going to throw an equal sign and figure out the solutions to these. After today, we now have 2 ways to solve quadratics. We looked at the first way back at the beginning of the year. We've been solving by square roots throughout this first part of the year. That will never go away. Pythagorean theorem, that's what typically is used, never goes away. Now, if the Pythagorean theorem doesn't work, we have ourselves now our new backup. This should be solved by factoring, so from this point on, solved by factoring is going to be popping up. And then eventually, sometime second semester, when factoring doesn't work, square roots doesn't work, we'll look at another backup, but we're not there yet. So let's solve by factoring today. Let's do this, boys and girls. All right, let's do this. Letter A to start off with, a little bit of a warm up here. We've got two variables, right? What I would like you to do is, based off of kind of what's going there, think about maybe some solutions. What would C have to be, and what would D have to be? In some way, somehow, that they would both work out to get me a value of 0 on the right hand side. Think about what C would have to be and what D would have to be, so that when you plug it back into the equation, that I develop a 0 on the right hand side. Okay, give you a second. There's some options out there for you. Okay, and we'll talk about how those options really come into play. But just think about what would C have to be and what would D have to be, so that when I plug those back into the equation, that they turn out to become 0. Give you a second. Just think about that. Right now, first time through, there's several answers you can throw out there, but then we're going to narrow this down. So eventually, we only get 2 specific answers. Okay. So what would C have to be? Plug it in. D, plug it in, so that they both turn out to be 0. All right. Anybody have a thought? Caleb? All right. Somebody help Caleb there? Silence?
But if C was 5 and if D was 1.
Okay. So let's take his suggestion. He's saying C is 5. And so if I plug in 5 right there, and then he said D was what? 1. Let me write that 5 a little bit better. Does this turn out to be 0?
Yes.
What's 5 minus 5?
0.
And what's 0 times anything? Oh, Brianna. 0. So, does that turn out to be the same? Sorry, I didn't say same, but does that turn out to be a true statement?
Yes.
It definitely does. Okay, that's an option. Anybody have another option there? Eric?
I would think that D could be 0.
Okay, so Caleb, just give me a number. Just give me a number then. Just give me a number. Any number.
3.
3, 7. Let's go with 37. Okay, 37 minus 5 there. But then Eric said D would be 0. Does that somehow turn out to be a true statement?
Yes.
32, and 32 times 0 is 0. Okay, that sounds good. Bless you. Let's carry on to the next one. All right, let's do letter B. Same type of question, right? I changed number around. Now, what Silas suggested to start off with, I'm kind of on the right path with that one. So he said what? On the first one, C to be 5. And what Eric said, I'm liking that as well. He said what? D should be 2. What Silas and Eric suggested, continue on those 2 paths, because they're on the right track there. So on the next one here, what would maybe C then need to be, based off what we just talked about? C maybe needs to be -7 plus 7, and then D, let's just throw out a random number, 4, and then I'll do with Eric. What is that, 0? And 0 times anything is still 0. That checks out, right? And then Eric said what? 0 for D, right? So let's just take what? 5, sure, which is 12. And that is seeming check out just fine. All right, let's kick it up a notch here. Let's go blast from the letter C. Based off what we've been doing, first thing I'm noticing is what number keeps appearing quite a bit. Keep that in mind. Same thing on letter C. What would C or D, C and D have to be, such that I can somehow get that to turn out to be 0 there at the end? Okay, Caleb's up here suggesting a -2 and then a -3. So let's take his -2 to start off with. It's -2 plus 2. And you said -3, Caleb?
Mhm.
What's -3 plus 3? Oops, that's not what I want. Question mark there. And that's also 0. What's 0 times 0?
0.
Does that check out? Still checks out, right? Alright. So I kind of had you start kind of guessing a little bit on, and then Silas and Eric started putting us on the right track when Caleb started to see the pattern as well. What we were getting into is solving quadratics, and leads us to a new property today, which we call the zero product property. When you've been factoring those into your two quantities, what we're going to now do is go one extra step and try to figure out what does that variable have to be by using what we say is the zero product property. And all the zero product property says, say that 5 times fast, okay, is we want that to somehow become 0. And what we're going to do is take that two quantities and set the first one to 0, set the second one to 0, and in some way, somehow figure out what does A and B have to be. And what Caleb did on that last one is exactly what we want to do here, okay? He realized, hey, in order for C plus 2 to become a 0, because I need a 0 in there, C has to be -2. He then suggested, hey, D plus 3, D has to be -3, because that has to become 0. And when that becomes 0, that also gives me the solution there. So what we are going to start using today is what we call is the zero product property. We want to make sure we are in factored form. And then the next thing we have to do is, if it's not in factored form, do our factoring skills and put it in there. So let's start off with letter A. First off, letter A, this is what we call factored form. You want to be in this factored form. Everything that we've done up to this point, we've not been in factored form to start off with. We've been in standard form. And when we say standard form, that is where that ax squared plus bx plus c, that's what I keep saying, standard form. In quadratics, we got standard form that we start off with, and then you do some work, you somehow get it factored into two quantities, and that's what we call factored form. Now I'm going to throw one small twist onto things. When I say it's standard form, I want to make sure it is set to 0. If that equation is not set to 0, as we will see here very quickly, then you need to tweak it, rearrange it, set it to 0, and then factor. So you got to put it in standard form. So that's what I mean. If you're not in standard form, rearrange it, make sure it looks like that. Now factor. So when we go back and look at letter A, somebody's already done all the heavy lifting for us. They've already factored it for us. So what we need to do then is split up these two quantities into two small equations. And we just need to use our solving equation skills to get our two solutions. Typically we get two solutions we set in quadratics. So here, don't overthink this now. This is just plain old linear equations. We go back to 5th and 6th grade here. You don't get anything more complicated than a two-steppy linear equation here. On this one, how do you get x by itself? Just add 10, and x is 10. That's one solution. And then on the other one, don't overthink this. This is as rough as it gets. This goes only back to 5th and 6th grade right here. Add 1, and then divide by, and what's 1 divided by 2? 1/2. That's my second solution. So I can plug in either x as 10, or I can plug in x as 1/2, and either way, that turns out to be 0. So what do I mean by that? If I plug in 10, well, what's 10 minus 10 here? 0. Now what's 10 over here, or sorry, 2 times 10? 20, and what's 20 minus 1? 19. But what right here is the key. What's 0 times anything? 0, and it checks out. So the solution 10 works, but also the solution of 1/2 works. It works with this right here. What's 2 times 1/2? 1, and what's 1 minus 1?
0.
That becomes 0 right there. So either one of these is going to be our solutions here that are working for us. Okay, we keep both solutions. We're not in any type of word problems applications right now. Later on down the road, we'll talk about that. But this is what we're going to be at today. We're going to use our factoring skills to get to this point. Let's go to letter B. On letter B, this is already in factored form. How do I know it's in factored form? I can see the structure right here where we've got the GCF pulled out, x plus 3 left over, and most importantly, what does it equal? It equals 0. So I don't need to distribute. If you distribute back in there and factor again, you've just gone around in circles and chased your tail, basically. Okay? We're just going to go and set each one to 0 using what we call is our zero product property. And you just got two mini linear equations to solve. That first one, divide by 2, what's 0 divided by 2? And on the other one, all we have to do is subtract 3 and x is, and there are my two solutions. If I plugged in 0 right up here, this one zeroes out, still checks out to be 0. If I plug in -3, when I plug in -3 right here, this zeroes out, and it still checks out. Okay, that's what we're doing today, is solving these out now. It's nothing crazy. We're just taking the next step of solving using this new property. All right, let's take a look at letter C. Letter C, this has already been factored for you. We can tell it's in factored form. Cool. Now, out front this time, all right, it's in factored form, but out front, what this means is we had a GCF of -7. Does that -7 include a variable? No, I don't care about that -7. I care about it if it has a variable there, but on this one it doesn't. I don't care about it. Now, in letter B, did I care about that 2x? I did, because the 2x has a variable there with it, right? So this is here on letter C. I'm going to take these two quantities, set them both to 0, and get my two solutions. And don't overthink it right here. Subtract what? Yeah, subtract 3, divide by 2, and x is -3/2. And on the other one, what's my other solution? It's just 5. Okay? I only care about it if it has a variable with it. The -7 did not, don't care about it. All right, let's throw in a SAT twist to things. We've seen this before. All right? They give you, this is, again, straight pulled from the SAT, from the 9th grade, 10th grade, 11th grade test. They all look pretty much the same. They switch up the numbers. You got to realize somebody's already done the hard work for you. This is in factored form. Give me my two solutions. I break them up using my zero product property and get my two solutions. And what does one solution turn out to be? X equals, and the other solution turned out to be. Now, if this was multiple choice, all right, they might phrase a little bit differently and ask you what's the two solutions here. You would find the one that says -13 and 10. It's not. This is our grid of response. And as I think I said to you last week, we can never grid in a negative answer. So they put this little bitty part right here. When they say x is greater than 0, yeah, that is code for it has to be positive. So I toss out the negative solution, and what do? I bubble in the 10. Does it matter where that 10 goes? Nope, just use some common sense. Okay. Bubble in 10 right there. The first two columns, the middle columns are the last two columns on the right. That's fine. Just don't put a space kind of in between the 1 and the 0. Why would you do that? Okay. And also, I don't care if you put that up there. It's just for your sake, but you better make sure you bubble those in. If you do not bubble any of that in, even though you got 10 up there, the SAT, it runs through your computer. That's not looking at that. It's looking at the bubbles. Okay. So far, we've been in factored form using our zero product property. Now the back side, let's combine our days together here now. We can tell we are not in factored form. So what we are going to do now is use our skills to put that into factored form. So let's go through our steps. Our steps are not changing. Are you in standard form? Yes, we are. Is there a GCF up there? 7, 4, and 3? No. And now let's go ahead and identify factors of A and factors of C. Okay, I'm not doing anything different. Okay, A is 7, B is -4, C is -3, factors of A, factors of C. Factors of 7 are, factors of -3 are, And what's got to be true about my signs? Sames or opposites? Okay. And then let's build it. 7x starts to build it with 1x. And where the plus and minus go, where the 1 and 3 go, I mean, that's what we've been trying to figure out the last few days. And based off the mini quiz from yesterday, we are looking very nice on that. Again, this is multiplication I'm doing in my head, trying to figure out what do we got to get to? A -4. So figuring out that combination, that's the name of the game there. How can we get to a -4? Make sure to go in the right locations and with the right signs. Alan, what's your suggestion there?
+3 -1.
So let's take her suggestion then. You said 7x plus 3 and -1. So always check your guess. So right there, 7x -1 is -7x. 3 and x is 3x. And what's -7 plus 3? Yep, checks out. We're good to go. All right, now here's where the silly mistakes happen. You are factored. Great, but you're not done now. A lot of students will circle the answer and move on. And you just said, hey, screw the equal sign. This is not an equation, it's an expression. Well, you can't just magically do that. What we need to do then is carry it along. Equals 0. And now that we are in factored form, now you can go and do what we did on the other side today using our zero product property. Okay? So what do we have here? Get our two solutions using our zero product property. Right here, again, don't overthink it. This goes right back to 5th and 6th grade skills. 7x plus 3. Subtract 3, right? And then divide by 7. -3 divided by 7 is not pretty. So we leave it always as a reduced fraction. Okay, don't ever give me the decimal. Never. We didn't do it on square roots unless the direction said to. We always did simplest radical form. And this will be the same thing here. And what's the other solution there? X equals 1, right? Give me both of those solutions. Okay. Now that's as crazy as it really gets. That's kind of the twist for today, using the zero product property. It's nothing major. Really all we're doing is this last new step, setting up two little mini linear equations and solving it out. All right, let's take the next one there, letter F. Is in standard form. Go through your steps in your head. I'll read them out again. Do we have a GCF there? Nope. All right, let's list them out. A is 3, B is, and C is factors of A, factors of C, factors of 3. How do you get a 1? Well, I just said it. How do you get a 3? 1 and a 3. How do you get a 10? And what's got to be true about my signs? Sames or opposites? Thank you, Parker. Build it. 3K, 1K builds it. And I'm trying to figure out that combination that gets me to a -1. So I'm standing up here thinking 3 times 10 takes me, what, to 30? Way far away from a -1. Probably not going to happen. 3 times 5 is 15. Still pretty far away from -1. But don't forget about the 1 and the 2 and pairs with it. So Caleb's here said 3 times what? 2 is a 6. A little bit closer to -1, but it's paired with that 5, right? So I'm taking that suggestion here. Again, in my head, I'm thinking, 3 times 2 is 6. 5 and K is 5K. And I'm always doing this head, hey, I know I have to have opposite signs, but to somehow a 6 and a 5 somehow give me a 1. It does. It takes me, what, either to an 11 or to a 1. And it definitely does. So Caleb said, what, -2 and a +5. Great. Don't stop, though. Now you got to train your brain to keep going a little bit further. It has an equal sign. It says solve. Give me the solutions. So now we break it up using our zero product property, and then we get our two solutions. What do we got? Subtract 5, divide by 3. Not a nice number. Always leave it as a reduced fraction. And the other one is, yep, that's it. All right, keep doing a little bit more. As I see the next couple ones, first thing that jumps out to me is they're not set to 0. So if they're not set to 0, that's what standard form means now. When we have an equation, standard form kind of slightly changes up depending on what's in front of you. Set those things to 0. So on letter G now, what do I have to move to set that thing to 0? I have to move the what? Yep, the 24. I always want my lead coefficient to be positive. So a squared minus 2a, don't touch, that's good to go. It's at 24, we went on the other side. So what do we got to do with that 24? Yep, we got to subtract it, right? It's a positive 24 to move it to the other side. Those are your solving equation skills you learned way back in 5th and 6th grade then. So subtract 24, and then go through your steps now. Now we're in standard. Is there a GCF up there? No. Identify A, B, and C, factors of A, factors of C. We're not doing anything more crazy than what we've been doing. We've done rearranging before on standard form. Now it has an equal sign. Who cares? Still rearrange it. How do I get a 1? Yep, in 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 and nope, and then we repeat ourselves. And for the 50th time in here, what's got to be true? Same signs or opposites? The 1s start to build it. 1a, 1a. And we're trying to get that number of -2. This one should be, yeah, this one you should know right off the top. Because that a is 1, you don't have to really worry about any extra multiplication there. Okay? Yeah, 4 and 6 should definitely be the case. And which one gets the negative on 4 and 6? Yep, 6 does. Again, doesn't matter the order I put those. Not really here. Just make sure what's in the quantity is exactly the same. The quantities can be rearranged. And then now go that one more step and get our 2 solutions. One solution is 6, and the other solution is -4. Alright, let's move it on. Let's do a couple more here. I got some kind of random ones now out there, good ones to talk about. Alright, let's take a look at letter H here. Alright, again, I notice this is not in standard form, it's not set to 0. So it's not set to 0, move it around. And what do we need to move on this one? We gotta move that -10, and then how do we move that -10 to the other side? Now when you add it on over, please make sure you add it with the same like term. What's its like term on the left hand side?
30.
Yeah, small things like that. And then run through what we've been doing the last week now. Okay. A turns out to be 1, B is what? -13, bless you. And C is 40. Factors of A, factors of 40 are a crap ton. 3, no, 4 and, well, 2 and 20, right? 4 and 10, 5 and 8, and I think repeat yourself after that. What's got to be true about my signs? Same or opposites. And what is that the case of? Pluses or minuses? Yep, minuses. And this one you should be able to kind of just fall into. Yeah, it's because of A is 1. When A is 1, that's as simple as it gets. Okay, you should be able to just kind of fall into that of 5 and 8. So then go that one more step, use your zero product property, and the solution is 5. And the other solution is 8. There you go. Okay. So if it's not in standard form, rearrange. All right, let's look at the next group here, I and J. All right, on letter I, what's the first thing that jumps out to you on I? How many terms do I have? 2. When I see 2 terms, what that means is one of those is going to be 0. It's in standard form, we're good to go there. But which one is 0? The B or the C? C is 0. So when C is 0, as it is in this case, I've been trying to harp on to you guys, you got to do the GCF, okay? So you're going to do the GCF. You're not going to factor A and A and C. You're just doing the GCF. What's the GCF here? 6x, correct. So we're going to take out a 6 and an x, gotcha. Show me what you have left over. Divide by 6x. You take out a 6x there, and yeah, we got x and plus 2. You've gone from standard form into factored form. It's set to 0. That's nice. We're good to go. And what I see here is, go ahead, Bill. What I see here happen is students only give me one solution. Sometimes that happens, but here we should be getting 2 solutions. What students usually see is the x plus 2 and say the solution is -2 and move it on. So what's the other solution? At the very beginning of today's notes, I gave you something like this. Just because it's not in parentheses, who cares? It's got an x on it, so we care about it. And 0 divided by anything is 0. Now, as you start doing the practice tonight, this week, you're going to find out that any time you have C is 0, one of the solutions is always going to be 0. It's every time that's true. Whatever the other solution is, just depends on the problem. But if C is 0, you don't have a constant, one solution will always be 0. All right, last one here, letter J there. Again, I step back, that thing looks like, it equals 0. It's obviously not in standard form, but one of the things I've been trying to have you focus on here with this type, the GCF is right there in front of you. Now you can go through and distribute the 2x, distribute the 5, put it in standard form, and then factor, and you're still doing it, but by that time we could be done with this. I want you to see that structure where x minus 3 is in both of these. That's a quick pull out of a GCF. If I take out an x minus 3 from both terms, what am I left with? A 2x plus 5. And all of a sudden, I went very quickly into factored form. Okay? It's not wrong if you distribute combined like terms, put it in standard form, and then factor that out. It's just taking a lot longer than it needs to be. See that structure there. And then lastly, get your 2 solutions. One solution is what? 3. And the other solution, you can, I know, do that in your head. Subtract 5, divide by 2. And what is that? -5/2. Okay? All right. That's the new part for today. One small kind of step with solving now. Now, for the time that we have left, looks fine. Let's do, we'll do some more practice tomorrow, right here, as you can see on day 2. Let's just do curriculum number 3, letter A, and we'll call it a day. Okay, let's reverse it. All right? At some point here, not probably this year, but next year, you're going to start building a lot more quadratic equations based off solutions. This is just the first step. Look back at your work we did up above. If I got one solution to be 4, what did it have to look like for the quantity? If I get another solution to be -3, what did that have to look like in its quantity in the step above? So again, look at what you just did up above on all of these. In order to get a solution to 3, what did it have to look like? It had to be x minus 3. So if I say, hey, one solution is 4, what did it have to look like for that quantity? That's it. Yeah, that's it. In order to get a 4, we had to do its opposite. It had to be x minus 4. And in order for us to get a -3 as a solution, what had to be first there? The quantity had to be? Yeah, that's it. Going backwards on that, kind of working way back up. And that's all I wanted from you. You just built the equation now. If I get a 4 as a solution, that checks out. If I get a -3 as a solution, that checks out. That's it. That's all I wanted for you. The direction said, write it in factor form. So we are good to go. I want you to take those solutions backwards. What did that equation have to look like in order to get those specific solutions?
This says like x equals 4 or x equals -3.
It will always be like that. So x could be 4 and that works out for the equation, or x could be -3 and that also works out. Yeah, but when we write the equation, then you got to count for both of those. On the last one here, we'll call it a day. Same idea. In order to get an x equals -4 solution, what had to be true in that quantity first? It's its opposite. It's its inverse. Had to be x. I'm just going to write down here. Had to be x plus 4. Okay. Now for 0, we did one up above a few minutes ago. Where was it? It's right here, right? So in order to get a 0 as a solution, you had to have something like 6x equals 0. Or 2x plus 0, 2x equals 0, or 5x equals 0. Or you can just be lazy because we don't know what's going on with this problem. There's not a lot of information. Because it's just 0, we can just say it had to be x. Okay? It just had to be x. Now, it doesn't matter where that x goes. It could be out at the end of it or at the front of it. Who cares? Okay? But in order to get solution, you just had to have an x up there. Okay? Now, Algebra 2, they're going to give you more information to have you create more specific equations. But we're not there yet. We're just laying the groundwork for you. Okay? Tomorrow we'll do a little bit more practice on things with solving, but that's essentially it. All right? That's essentially our last lesson there of factoring. Solve by factoring. We now have two methods. Solve by square roots, and now solve by factoring. Now we're going to hit you hard on getting you guys just not good at factoring, but getting you great at factoring. Okay? So let me pass out the assignment here for you today. Got about 5 minutes left here, so let me pass it out to you. Here it comes. Now, the mistakes that I usually start seeing though, after we do this day right here, all of a sudden, everybody starts solving these questions out. We only solve it out if it says solve, it has an equal sign. Otherwise, we don't solve, we don't use our zero product property. So what do I mean by that? So get the assignment here real quick before our 5 minutes is up, or our 4 minutes is up. Okay, on tonight's assignment, which I did not bring up actually. Let's take a look at 1 through 6. 1 through 6. Are there any equal signs on 1 through 6? Or does it say solve in the directions? No, it just says factor. So all you're going to do is, like you did everything up to this point, you're just going to factor out and stop. Don't put an equal sign in there. You just can't add in an equal sign to it. You're just going to factor and stop. And then after that, number 7, 8, and on to the back page, all of a sudden I see all these equal signs, and it does say solve. So what are you going to do? You're going to factor it, and then go that one extra step and use our zero product property from today. So that's usually where I have always about 2 or 3 kids every class. Does everything get solved? Nope. Read the directions very carefully. Okay. So tomorrow we'll go through things. Same deal. All right. Answers online. Use it. Don't abuse it. All right. If you just turn in, especially like the solving part now, just x equals 5 and x equals -3 and there's no work there, okay, that's where that's not full credit. You got to make sure you are showing the work there. It is a little bit more involved. Try to keep track of it in your head. Okay? So that's where we stand on things at the moment. All right, who's absent today? I will have those quizzes done back for you tomorrow. I have to tell you about them, upload them, but